This is a project about detecting fraudulent transactions using AI. As compared to credit card fraud, which is becoming more prevalent as online banking and retail increases worldwide. We're going to do this by creating an automated early detection AI that can quickly learn new trends in financial fraud. This will allow customers to be notified if their information has been stolen and allow them to act quickly to prevent any long-term damage to their credit and allow credit card companies to minimize the financial losses from fraud. Some similar topics we'll be discussing in this project that we've discussed in the course is, firstly, agents will have to deal with a lot of uncertainty, which is similar to some topics we've discussed recently in class. Also, we want the model to learn, like some other topics we've covered, what financial patterns indicate fraudulent transactions. Then we have to use probabilistic inferences to assess what transactions are most likely to be fraudulent. Finally, in reference to what we talked about in the beginning of the class, we work in a fully observable, single agent, dynamic, sequential, deterministic, discrete, and an unknown environment. The solution we decided on for this project is to create a generative adversarial network. The first step of this is to create a generator model. This forms a compressed representation of the key insights in the data using hidden variables. This allows us to suss out some of the key aspects of the data that will indicate what transactions are fraudulent and what transactions are not fraudulent. Using these insights, the model will then generate new random samples that almost are identical to the real transactions from the data. Then we want to create a discriminator model. This just assesses if the samples are from the training set, i.e. real transactions, or from the generator, i.e. generated transactions. And we use just a very typical binary classifier, yes or no, is this fake or not. To train these two models, we want to penalize the discriminator model for missing created samples from the generator. Similarly, we want to penalize the generator model anytime one of its generated samples is caught by the discriminator. Pretty much we're trying to create a generator that can fool the discriminator, and we're trying to create a discriminator that can always catch the generator. And this process will continue until the discriminator cannot assess what samples are real and what samples are not real. Then, in order to create predictions, we'll store the generator model, which has been fully trained and has a very good representation of key insights from the data to predict what transactions are fraudulent. Some key resources we have available to us is the AMI textbook that we've been using throughout the class, lecture notes. We found some online repositories as well that has sample code that kind of allowed us to assess what other people have done to create one of these complicated general adversarial networks. And most critically, we found a simulated data set of financial transactions that we were able to use as a plethora of data for us to train our model. Now we'll look at the schedule for the remainder of our project. First, we'll finish the EDA for our data set, which allowed us to identify some key insights before we started training our model, and we were able to perform some feature engineering, which should increase the performance of our model as well. Then we created the general adversarial network model by creating the general framework for the generator and discriminator models to ensure they're working properly before we begin training them. And we're almost done with steps 1 and 2, which allows us to begin training the models very soon. We'll need a virtual machine to do it in the background, since we'll need about 2 to 3 days of CPU time, since there's about 60 million transactions in the simulated data set, which will take a long time for these two models to be trained. Once they are trained, though, we can test them by using the generator model to predict what transactions are going to be fraudulent on some set-aside test data. Then we'll create some visualization tools. We just decided it'd be a good idea to create a method that will allow a user to quickly find what transactions are identified to be fraudulent, just to increase the usability of our project. Finally, any other tasks that need to be completed will be done at this point, whether it's some documentation that needs to be updated, finish up new reports and presentations. And with that, thank you for listening to our initial presentation. Thank you.